Question 9. Which monomer forms this polymer? But1ene, E-but2ene, Z-but2ene, beta-propene. Now, if this is which monomer forms this polymer, so what will happen is we'll have everything. We just have a double bond here. And before I even do that, I can see that the longest carbon chain is 3. 1, 2, 3 here, or 1, 2, 3 here. And so the answer is metapropene. Question 10. Which equation represents the propagation step? So that looked a lot harder than it was actually. Question 10. Which equation represents the propagation step in chlorination of methane? Hydrogen free radical plus chlorine HCl plus Cl dot. Cl dot plus CH4, CH3, Cl plus H dot, CH3 dot plus Cl2. Well, this is termination. Yeah, that's a termination. That is definitely not correct. The answer is C. You don't use a hydrogen free radical. You don't form a hydrogen free radical. Which is the overall equation for the reaction of CCl3, CH2, CCl3 with an excess of chlorine in ultraviolet radiation? There's no free radicals in this case, but if we add chlorine to it, so what is CCl3, CH2, CCH3? Okay, so for part A, CCl3, CHCl, CCl3 plus a half H2. Part B, no. The answer is C. Yeah, because we wouldn't form hydrogen, so it would be either between B and C, and if we look at B and C, and C is the correct balanced one. Question 12. Most scientists believe that ozone upper atmosphere should not be allowed to become depleted. Which is a valid reason for this belief? Ozone absorbs ultraviolet radiation. Yes. Ozone helps prevent global warming. No. Helps remove pollutants such as chloralkanes. No. Efficient disinfectant. No. Question 13. Which is not a possible product or reaction of this compound with potassium hydroxide? That definitely is a possible product already, replacing the Br group with OH group. And then you've got obviously your elimination, hydroxide ions. You can either go nucleophilic substitution or elimination. And with the elimination, let me go through it here. Elimination acts as a base. No, elimination acts as a base, takes a proton, and then the double bond forms. So you'd either get the double bond here or here. You can never get the double bond here, because if you go here and form the double bond here, or you go here and form the double bond here, but you can't go here and then form the double bond here. It doesn't work like that. So C is definitely correct. Same with D. B is incorrect. Question 14. Infrared spectrum of an organic compound is shown. Which compound could produce a spectrum? So 1500 centimeters to power minus 1. We do not want to look at this for this question. That's fingerprint region, the region less than 1500 centimeters to power minus 1. Which compound could produce a spectrum? So we've got a peak here, we've got a peak here, pK 1500, 1600, 1700 pretty much. I've got pK 100, 200, 300, like 350, 350. So if we look at table A, infrared absorption data, and what we're looking for, a peak at 700. So a C11O functional group, that's between 1680 and 1750. And then we're also looking for, what was it, 3300, something like that. So OH group in alcohol. That's for NH amines, but that would be between that. So yeah, OH alcohols. Okay, so can it be but1-ene? Definitely not, because that is not an alcohol and it's not got a C11O bond. But2-ene, but-2-ene-1-ol. It's got OH and it's not got C11O. Is an alcohol though. Butanoic acid, yes, because of carboxylic acid, C-double-bond-O, OH. So definitely, and then D definitely not, because that's just an alcohol. So 14. One second, guys. So we've got methyl propene, that ozone absorbs ultraviolet radiation, that which compound could produce a spectrum? I don't know what I did wrong. Look here, peaks point downwards, yeah? That's definitely OH alcohol. Butanoic acid. If we draw out but, just 2-ene-1-ol, methane, ethane, propane, butane, alkene, the OH group. The answer is B, but-2-ene-1-ol. Question 15, which reaction results in overall change in shape around carbon atom? Reaction polymerization of tetrafluoroethene. Which statement about the industrial production of ethanol from ethene at 300 degrees Celsius is correct? That's incorrect. Only temperature can affect value of Kc. I keep saying that for every one of these questions, but you can just eliminate one option or two just because of the idea. It's usually one. Only temperature can affect the value of Kc. Increase in temperature. Okay, now let's do the increase in pressure, decrease the equilibrium yield of ethanol. We've got 2 moles here, we've got 1 moles here. If we increase the pressure, we're going to shift to the side with fewer moles of gas, which is the right hand side. So that's ethanol, so it's actually going to increase the equilibrium yield of ethanol, so that's false. Increase the temperature, increase the equilibrium yield of ethanol. Forward reaction is exothermic because delta H is negative. So if we increase the temperature, it's going to shift to the side in the opposite direction, the endothermic direction, to oppose the increased temperature. Therefore, it will decrease the equilibrium yield of ethanol. Increase temperature, decrease the value of Kc. That must be correct. But if you look at it, if we increase the temperature, we're going to have more reactants, and Kc is products. Kc is equal to products of power of P over reactants. To the power of R, and we're increasing the reactants, so the product stays the same. It's like doing 10 divided by 2 and 10 divided by 100. 10 divided by 2 and 10 divided by 10. Which one's a bigger number? Obviously this one, because that's 1 and that's 5. And that's what happens when we increase the reactants. So it will decrease the value of Kc. What is the minimum volume in dm cubed of air needed for the complete combustion of 1 dm cubed of methane? Assume air contains 20% of oxygen by volume. So we've got complete combustion of methane, 20% of oxygen by volume. Methane, for complete combustion, we're adding oxygen, forming, because complete combustion we ensure we form carbon dioxide and water. We've got plenty full of oxygen. Assume air contains complete combustion of 1 dm cubed of methane. Air contains 20 centimeters cubed of oxygen by volume. So 20 divided by 100, 0.20. Minimum volume of air needed for the complete combustion of this. The air contains 20% oxygen by volume. If it's 1, 20% oxygen by volume, so 0.20 moles of oxygen. Complete combustion of 1 dm cubed of methane, no. 2, let's try 10. So if we do 10 dm cubed of air, and 20% of 10 is 2, and then 2, 2. The answer is 10D. That's a bit of a tricky question. Yeah, that's pretty tricky. Question 18. Which is the IUPAC name for this compound? Okay, well, we can already eliminate 2 just by how well we know E and Z isomerism. Which one's E, which one's Z? Actually, we can't. This one's going to be even trickier to do. Oh my days. Because normally, you know, when you have them, you don't have a chain. In this case, you do. So what we have to do is find out the MRs of these. And trust me, are the MRs the same? CH2, CH3, CH2, CH2. Yeah, they are. So, because 2 groups are on the same side, these 2 groups have the same MR, and on the same side, it's got to be a Z isomer. The Z on the same side. Just to remember it. For Z isomers, that and E isomers when they're opposing each other. So it's either C or D. And that is really no, it's not. No, it's not. It's not. So if you look at this, 3-fluoro ethane, 3-fluoro hex, 1, 2, 3, 4, 5, 6, 3-ene. Yeah, so is E isomer. So the answer will be A, 18A. Question 19. And then, oh my days. Find out the moles of this. Find out the moles of this. Moles concentration and volume. 0.0375. And it's quite clearly going to be either C or D. But I'm just assuming it's C. If we actually look at it, 1, 2, 3, 4. The answer is C. I was just like, it can't really be D because that's massively, like that would be way bigger than 0.0375. But the answer is, yeah, C. Question 20, which compound has the greatest MR? It's actually going to be A. It even looks like a real compound, but the answer is A. Because you know, these double bonds, if you think about it, we've got 1, 2, 3, 4. So you can see, because we've got 4, you know, sticks, 1, 2, 3, 4. They've each got 4 carbons. 1, 2, 3, 4. Actually, 1, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1. They've all got 4 like sticks, yeah. This one's got a double bond. 1 double bond. Therefore, it's going to lose 2 H's. That's also got a double bond, so it's going to lose 2 H's. And this, because it's a cyclic structure, it already loses 2 H's. So the answer is A. Which compound has a empirical formula C2H4O? Butanol, ethanoic acid, ethanol, methylpropanoic acid. Methanol, ethanol. Let's draw them out. Methane, ethane, propane, butane, aldehyde. Methylpropanoic acid, C3. No, that's propanoic acid, so we need another, we need a methyl group, so CH3. Okay, so we're gonna have C4H, methane, ethane, propane, butane, H1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. methyl propanoic acid, propanoic acid, methane, ethane, propane. There. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 02. But that won't simplify to the empirical form of C2H4O. It's got to be C4H88O2. So I think we minus, why do minus 3 hydrogens? C propanoic acid. Yeah, because if you think about it, we always have the R group C double bond. No, if we have carboxylic acid, and definitely need to practice drawing compounds and molecules, that's for sure. The carboxylic acid, yeah, RC double bond OH. So we have the R, the alkyl group, C double bond OH. It's propanoic acid, methyl propanoic acid. So it's going to be C3H. 1, 2, 3, 4, 5, 6, 7. There we go. So it was what I originally thought, because it's propanoic acid. Yeah, methane 1, 2, 3, 4, 5, 6, 7, 8. Should be hydrogen there. O2, and then if you divide that by the 2, we'll get C2H4O, and therefore methyl propanoic acid is the correct answer. So D. Which compound cannot be produced by oxidation of this alcohol? So this is being oxidized. What is this? Well, let's draw this out actually, because I feel like that will help us. Because if we determine whether it's primary, secondary, or tertiary, that would probably help us. Well, that is clearly a primary alcohol. So if we oxidize it, we're going to oxidize it. Primary alcohol, oxidize it, and we form a secondary alcohol. So I feel like that if we form a so we can't form a tertiary alcohol. So one of these has got to be a tertiary alcohol. Now, primary alcohol oxidized to, not secondary alcohol, to an aldehyde, and then aldehyde to carboxylic acid. So the carboxylic acid and aldehyde can be produced. Whereas if we draw out this CH3, yes, there we go. So I have a feeling it's going to CH3, C double bond O, CH3. What is that? That's a ketone. That is a ketone. Don't know why I got confused. Primary alcohol oxidized to secondary is clearly to aldehyde. That's a ketone. We cannot produce a ketone by oxidation of primary alcohol. We can't. Secondary alcohols. So yeah, because that's a ketone, we can't produce it by oxidation of alcohol. Whereas this is an aldehyde, because the carbonyl functional group C double bond O is at the end. Functional group, that's aldehyde. We can produce aldehyde, primary alcohol plus oxidizing agent form aldehyde, and carboxylic acid. Yeah, because if the conditions are right, instead of forming aldehyde, immediately we form a carboxylic acid as well. Aldehyde, carboxylic acid. However, we don't form a ketone. So the answer is B. And then 23 was atomic economy for the formation of ethylamine in this reaction. A percentage atomic economy, classic question. MR of desired products over MR of all reactants times by 100. Ethylamine, which is the ethylamine? That one. That's a salt. That's a halogen alkane. That's just ammonia. Ethylamine is that formation of that. So it's either that or that. It's that. So MR of that. Well, nitrogen is 14. So it's going to be 12 plus 3 plus 12 plus 2 plus 14 plus 2, 45 m of desired products over m of all reactants times by 100. 12 plus 3 plus 12 plus 2 plus bromine, Br, which is 79.9, plus, well, I'm going to leave it as that, 108.9. And what you notice is that we've got 2 moles of ammonia. And remember, with atom economy, we include the moles in atom economy. We times the MR by the moles. That's okay what we're doing. So we plus, well, 14 plus 3, nitrogen 14, plus 3, 17, 2 times by 17, say 4. And obviously percentage, yeah, because all of these are given in percentages, times by 100. 45 divided by 108.9 plus 34 times by 100 should get 31.49%, so therefore 31.5%, therefore the answer is A. Okay, so M of desired products, ethylamine over M of all reactants, and do not forget, because there's 2 moles, include the moles in atom economy. The time by 100 because all these are in percentages, and you should get 31.5%. And that is the end of the multiple choice question.